Hello and welcome back to the Fusion 360 tutorial for beginners from the BCRC. Wow, that's a long name. Alright, let's begin, because I believe we left off last time rushed over here with our blade. And I promised to show you the fillet tool, the 3D fillet tool last time, so here we go. Up here on the top, F for fillet, we can use the fillet tool. So now you should click on these sharp corners to fillet them, and I'll demonstrate it in just a second. Once I finish clicking on all of these, you can go back in here and make all of these a curved corner instead of a sharp corner. That relieves those points from being a stress increaser. It relieves it from being a stress point, and it makes a smooth curve so that stress is more evenly distributed. So I can make that an 1/8 inch radius or something like that, and have a nice curved edge. Generally, you should do this for every single corner that you have on your design, but I'm just not going to do it on these endpoints because they're supposed to be sharp, as they're what's going to hit and impact the other opponent, as this is a blade. Alright, let's actually move on to some 3D stuff, and I'll do this by creating a really basic frame for a robot, just 3 parts, the top, bottom, and the middle portion, but also show you the ins and outs of how to do more stuff in 3D in Fusion 360. So I want to create something like this. This is Morberizer, which is a 1-pound robot. Built by one of the seniors last year, and it's kind of like a mini tombstone. It has that triangular back, this electronics portion in the middle and the left, and then the motor portion in the middle where we have all 3 motors mounted, and another massive triangle in the front to contain the weapon. So let's actually go ahead and create a very simple version of this. So I created a new file, named it 3D stuff, and I'll create a sketch on the bottom plane. Oh my goodness, what happened here? There we go, on the bottom plane. Alright, so I'll use the same technique as last time as I mirror the design, so I'll start off with just 1/2 of it. Start with the electronic component. R for rectangle, make it 1 inch by 2 inches. Another one, maybe make it 3/4 of an inch wide. And that's a great moment to show off the collinear tool, which I can use to make these 2 lines collinear to each other. Cool. Now to get that triangular back portion, I can click L for the L tool, since there's no triangle tool. And I can make a rough triangle. It doesn't have to be perfect, because we can make this a right triangle by using the perpendicular constraint just up here to make that perpendicular. And then I can, since this can be any length, I can define the length of that to be maybe 1 inch. Make that all constrained. And we'll do the same thing for the front. L for line, make a larger rectangle this time, and I can use that perpendicular constraint, and D for dimension. Make that 2.5 inches. Now it's time to mirror all of this, so click on the mirror tool, and I'll select all the lines that I want to mirror, and I'll mirror it over the x-axis. And click on the mirror line and one of these lines, and boom. Right, I don't really like the dimensions of this, but the cool thing is that we made this completely editable, so I can change this to 1.5, and that looks a bit more chubby and less fish-like. I don't know, it's a weird way to describe it. Now back in this file, you can see that there's a wall right here, so let's recreate that. So we can use that offset tool that we learned about last time. But you'll notice that when you just try to create an offset, it'll also add these other lines in between, and it'll just break when you try to do everything. So, just right here, I'll go back in the offset tool, uncheck chain selection, so you can click on singular lines, And from that point, you can select all of these and extrude it by -1/4 of an inch or so. And I can connect this back into a shape using the L for the line tool. So now it's a nice shape. Let's do some extruding now. Finish sketch, click E for extruding, and we can select all these shapes to extrude. So this is going to be this bottom portion. Think of this area. I'll extrude that. Oops, that went away. I'll extrude that by maybe 1/8 of an inch. Cool. Right, now time to extrude those walls. So press E for extrude, and we can extrude that. But this is extruding from down here, and if I extrude it, it's just going to cut through the portion that I already extruded and made. So I can click on the start pop-up right there, and then change it to object. I can select the top of the just extruded body, and from there, oops, Fusion is breaking. Let me do that again. Extrude, profile, object from the top of that, and from now I can extrude it however I want to. But if I click OK now, I'll make it 1 inch, and if I click OK now, you'll see that this entire thing is one big massive body, which I don't want. So down here in the timeline, we'll talk about that a bit later, maybe next semester, once you get acquainted with Fusion 360. But I can give you a short overview of what it does. All it does is track what you do from creating the sketch to extruding. But I can also go back in this timeline, right click, and edit those features. And I'm going to edit it and make this operation a new body. Bam! So now it's 2 separate features. Right there and right there. You want 2 separate or multiple separate bodies as you build your robot. So it's easier to service, easier to manufacture, and if something breaks, you don't have to replace all of it. It's also easier if you want to iterate on a design, which is why Morebraiser right here has multiple different parts. Very complicated. And now let's create that top portion. I can extrude that sketch, or I can just be cheeky and extrude this portion right here, because you can extrude any face on an object. And I'll go back and click object and click on this the top of that and extrude it by -1/8 of an inch. Nice. Up. Forgot to make it a new body. Cool. Now, how do we clamp it together? That's the job for screws. But to talk about screws, we need to learn how screws work. Right here is a diagram that I found off the internet of how screws work. We have the screw, a material with a clearance hole, and a material that you thread into. So it works as a clamp. It clamps this material in the middle by screwing into both sides. It uses the head of the screw to press into this portion, and then uses the threads of the screw to clamp into the other portion to keep it all really nice and secured. And you can have multiple of these middle portions with clearance holes. And you can even use a lock nut or some kind of nut that you've probably seen to lock it in place on the end. If you don't know what a lock nut is, something like this is a lock nut. Just something to screw it in from the end instead of threading into an object. So these holes that the screw can completely go through easily, very easily, with no twisting or threading required, is called a clearance hole. And then these holes are called tapped holes down here. So let's make those, but first we need to position them. So let's go back into that sketch. You can double click on it in the drop down menu, and let's create points where we want to have these screws located. So down here in the create menu, we have a point item, point tool, and you should make that a shortcut. I set it as W because points are W's, and I can place maybe 3 points. You probably want to do more for your robot, but this is enough just to demonstrate the concept. Now let's make sure this point is actually in between these 2 lines, so we can click L for the line tool, make that a construction line, and draw a line between them. I can use that perpendicular tool to make this side perpendicular as well. To make this point exactly in the center, these two lines should be equal in length, so I can click on the equal constraint and to make them equal. Nice. I could do the same thing on this side, but I can also use the ever useful horizontal/vertical constraint, which I also keybind it to Shift A. You can keybind it to whatever you want or whatever feels comfortable for you. So now it's constrained. It only isn't constrained horizontally. We can use the dimension constraint. For that, I'll make it maybe 1/4 of an inch there, and between these two, maybe 2 inches. Down here, we can do the same thing, or I can show you a different way of doing it, which showcases a few more Fusion's capabilities. So I'll start off with horizontally constraining it, and the next thing I'm going to do is figure out the dimension, the distance between these 2 points. So I can click D for that, and click on those 2 points and click somewhere. It'll give me an over-constrained sketch warning, but you can just ignore this and click create a driven dimension, which is actually what I want. It's a dimension that already exists that I cannot edit because it is already defined by something else, by this offsetting value right here. But this constraint is really useful because Fusion 360 has a nice little feature with dimensions. So I'll dimension this with a D-tool dimension and dimension that to that. So as you've probably noticed, you can put equations in here. You can do 1 divided by 2 times 3. Math equations would work perfectly. But another thing that I can do is reference other dimensions. So I can click on this and click on this other dimension and reference it. Now I can divide that by 2 to keep it directly in the center. How cool is that? I'm just going to go and mirror the other side. So we'll click mirror, and I'll mirror these 2 points across a nice line, and bam. We can finish the sketch and then talk about the hole tool now. So these are just points that we've listed. I'm going to unhide the sketch on the left menu. But now let's actually think about creating those holes and just points into actual holes. To do that, we can use the hole tool that Fusion provides to us. I'm going to click on that and click on all these holes that I made. Nice. So you should see this pop up right here. So what you want, there's a lot of settings in here, so it's not exactly the easiest thing. Right up here I want a simple hole. Counterbore and countersink holes are for different types of screws, but a simple hole will work fine for us. And for a hole tap type, right now I'm just going to do these outer 2 portions, so I'm going to click on clearance, and the rest should be the same. Down here, since we're going to be using number 6 plastite screws, we'll talk about those a bit later, I want it to be NC, unified screw threads, imperial, and then I'll make this a flathead machine screw. That can be fine, and I'll make it a number 6 size. The bigger the number, the larger the screw size is. A normal fit is fine, but in this objects to cut right here, I only want these 2 outer pieces, not the middle piece of the sandwich, so I can uncheck that and create holes. Actually, I'll go ahead and rename these. You can double click on those to rename sketches and bodies. So I'll rename that to bottom, middle, and top. You should probably find better names for yours. Now that's the clearance hole of this talked about. Now let's look at the tapped hole. It's a bit more complicated, but since we're using plastite screws, it's a lot easier because you can kind of just choose anything. So back in the hole tool, click on all those 5 holes, and now I'm going to click on tapped right here. Give me a few more options. I'm going to go back to imperial, number 6, right over here. Designation is fine. This is different threading types, so 632 is fine. The class is also fine. You can make it whatever you want. Just leave it there. And in objects to cut, it's just the middle portion because the threaded hole is a lot smaller than the large hole. Fusion also does a nice graphic just to make it look like it's threaded as well. So the screw is going to go from the top and drive into this middle portion while clamping down on these top and bottom portions. We'll have different screws, so 1, 2, 3, 4, 5 times 2, so 10 screws, 5 from the top and 5 from the bottom. Hello future me back here, and I now realize that this video is much too long, so I'll cut it into 2 different sections. See you in the next one.